This final unit in the final module works with trying to solve quadratic equations. We will talk about several techniques, one of which is review. This lesson is about solving quadratic equations by factoring. So this 6.6.1 has been covered before, so I will go through it rather briefly, but please keep in mind we're going to solve quadratic equations. They are equations that could be written in the form ax squared plus bx plus c equals 0. And the only extra condition is that a cannot be 0. And that's another way of saying there must be an x squared term. All right, we'll use our different techniques of factoring. So let's take a look at some problems. I'll be doing these off to the side. We're also going to use what's called the zero factor property that says if a times b equals 0, then a must be 0 or b must be 0. So we will use that. The first problem is already factored for us. It has x plus 9 times x plus 11 is equal to 0. We know it would be a quadratic visually if you multiplied these by FOIL. The first term would be x squared. Not going to do that, but at least we know it is quadratic in nature. Because these are already factors, it's already equal to 0, I can use this zero factor property and say that either x plus 9 is 0 or x plus 11 is 0. That means x is negative 9 or x is negative 11. It says we're just going to list the answers and separate them with a comma. So I'll have negative 9, negative 11. It does not matter what order you write them. All right. The next one. Let's get a little bit of room. This one is also already factored for us. We have x times x plus 4 equals 0. Again, it's already equal to 0. If you distributed, you would have an x squared term, so it is quadratic. We don't want to distribute, but just to see that there is an x squared term. I have x equals 0 or x plus 4 equals 0. There's one of my answers. The other one would be negative 4. So my two answers are 0 and negative 4. Sorry about that unusual pause. All right, the next one. I have x squared plus 3x minus 40 equal to 0. Because of the x squared term, I know that it is quadratic. I have it equal to 0, so I can go ahead and try to factor. There are different factoring techniques. Because this is a trinomial, you could go off to the side and use a box method. Instead, I just use a trial and error method. I know I need an x times an x to get an x squared. To get a negative 40, one of these must be plus and one minus. To get a 40, it could be 1 times 40, it could be 2 times 20, it could be 4 times 10, it could be 5 times 8. One of these will be a negative, and one of these will be a positive. Their difference will have to be 3, 5, and 8. So I'll put the 8 here and the 5 here. That does give me a negative 5x and a positive 8x, which gives me 3x for the middle term. So I'm going to erase this. All right. Now I have the factors. The product is equal to 0, so I know that x plus 8 equals 0 or x minus 5 equals 0. So x is negative 8 or x is positive 5. In any order, we have negative 8 and positive 5. The next one, I have x squared minus 6x is equal to 0. It is quadratic. It is equal to 0, so I can go ahead and try to factor. This time I see a common factor of x, so that's x times x minus 6 is 0. Set the factors, both equal to 0, so either x is 0 or x minus 6 is 0. X equals 0 is one of the answers. X equals 6 is the other answer. So my two answers are 0 and 6 in any order. Number 5. I have 10x squared plus 68x equals 14. It is quadratic, but it is not equal to 0. So the first thing I'll do is subtract 14 from both sides so that I get 10x squared plus 68x minus 14 is equal to 0. And what I did was that step. Now, because I have a quadratic equal to 0, I'm going to factor. I always look for a common factor first, and there is a common factor of 2. That will leave me with 5x squared plus 34x minus 7 equals 0. Keeping the factor of 2, I'm going to look at trial and error. You can use the box method if that is the method that makes the best sense to you. Because 5 is a prime number, I know it has to be 5x and x. To get a 7, 7 is also a prime number, so I know I have to use 1 times 7. It does matter where I put them. I can put them in, try them, error, and go on. But I also know that I need one of each sign to get a negative 7. So I'm going to put the 1 there and the 7 there. The outer product is 35x. The inner product is negative 1x, and that gives me 34x. All right, so now, using the zero factor property, I'm going to write down something that's going to look a little strange. The product of all three of these factors is 0. So either the first one is 0, or the second one is 0, or the last one is 0, and this is where I'll get my answers. 2 equals 0 is a ridiculous statement, and the 2 as a factor is not the reason this is equal to 0. So that does not give me an answer. This one, I'll add 1. So I have 5x is 1, divide by 5. X is the fraction 1/5. And the last one, subtracting 7, probably just in my head, x is negative 7. Now be careful when you put these answers into my math lab. You'll have x is equal to, and you're supposed to separate these with a comma. If you use the fraction 1/5, make sure you get out of the fraction so that the comma is right there. A lot of people make the mistake of putting the comma and it ends up down there with the 5, and that is a mistake. And then the other one is negative 7. Okay. Last one. I have x squared minus 28x is equal to negative 3x. It is a quadratic, but it's not equal to 0, so I have to add 3x to both sides. So I have x squared plus 3x. Oh, I miscopied. Minus 28 is equal to 0. Okay. So it is quadratic. Now it's equal to 0, so I try to do my factoring. I know that I need an x times an x to get an x squared. I need factors of 28. I'm going to have 1 plus and 1 minus to get negative 28. Well, 1 times 28, 2 times 14, 4 times 7, those are my choices. I need to get a difference of 3. 7 and 4. The outer product is negative 4x. The inner product is 7x. That gives me 3x. Now I can use the zero factor property. I have x plus 7 is 0, or x minus 4 is 0. So x is negative 7, or x is positive 4. Those are my two answers. One last thing I want to say, or a couple of things. If I had, say, 2x squared plus 4x equals 0, it is quadratic, it is equal to 0. There's a common factor of 2x. And if I factor it out, I end up with 2x times x plus 2. When I use the zero factor property, 2x is 0, or x plus 2 is 0. Divide by 2, x is 0. Subtract 2, x is negative 2. Just to mention this, a common factor that is a constant does not affect the final answer. But a common factor that is an x gives me an answer of 0. The only other thing that is not mentioned in these exercises is factoring difference of squares. If you had x squared minus 9 equals 0, don't forget the technique for factoring difference of squares, that you have the square roots of x squared, the square roots of 9, which are 3, 1 plus, 1 minus, and you end up getting x is negative 3 or x is positive 3. You will not encounter any sum or difference of cubes in these problems to factor. So, factoring to solve quadratics involves using that zero factor property, which we had right up here. It is a very effective way to solve quadratics if they're factorable.